Hi, I'm David and welcome to LeisureBit, and today we're going to be installing some additional USB sockets. These ones that have a couple of USB-A quick charge and a USB-C power delivery, and we're going to be installing them in the back corners of the van, so one in each side, and that'll give us some extra capacity for charging things. Anyway, let's get cracking. Let's go through a list of the parts we're going to use for this piece of work. So first of all, and the most important bit, using two USB A and C sockets. The ones I've chosen have a USB-C power delivery and two USB-A quick charge. So in total we're adding 6 new USB outlets that we can use, 3 on either side. The cost of the USBs that I chose, I paid £15.99 each for. So that's a total of £32, just under. There's also, of course, the surrounds, which you don't have to use. I used the CBE surround for this one, but you can obviously use the C-line, and I'm basically drilling a blank for those. And I paid £1.99 for the blanks, which were actually C-line ones, and the fascias, or the outside bit that clips on, I paid for those, I think it was about £3, £4, something like that each. I think it finishes them nicer than just kind of insetting them in the hole. They also have the benefit that the slightly offset when you put the backing plate on, so you can screw the holder in at the back of the USB socket, so if you ever need to adjust it you don't have to faff on with the panel off. Then there's the cable. I used about 10 meters of cable in total. It's surprising how much you use when you're routing around things, and that cost me £1.20 a meter, and it's 2mm squared conductors in that, and it's twin wall, and I went for the round one because I find the insulation a bit better. I also used some conduit to run it in. When you're running it through the van, there are some sharp edges, so it just gives that extra bit of protection there, and then just keeps the cables in good condition and protected. Also needed some connectors, which I crimped on to connect to the USBs, and also some lugs to connect in at the other end, as well as a couple of fuse holders and some 10 amp fuses to finish the job off. I connected it into an existing circuit I have, which I created with a 40 amp solid state relay, which basically offsets the power that's drawn through the main van electrics, so that we're not actually running more power than it's intended for in there. Because if we fully load the USBs and plug everything in on each side, we're going to draw a fair bit of power there, so that just makes sure we don't overload the original electrics that were put in. And basically what the solid state relay does, acts like a traditional mechanical relay, but it's electronic, and you have an input which turns it on or off, and then that's done electronically, so there's no moving parts to break down in that either. And I went for the 40 amp one because I tend to size these things on twice the size I'm likely to use, just so that they don't run too warm. But you can get them in different sizes, from 10 amps up to 100 amps plus, and that was about £13 for one of those, so slightly more expensive than a mechanical relay, but in my opinion far more modern approach to it, and you've not got those mechanical parts to wear out. And I didn't need specific isolation there because it's on the low voltage DC circuit, so hence was okay to use that one. So fairly straightforward to connect up, as you can see there. You can of course just connect them directly to the battery because they do have an on-off switch, and from my measurement there's negligible power draw when it's switched off. You could just connect it straight up if you didn't want to do that, obviously making sure you fused it properly. I wanted it where it switches on when I've got the van electric switched on, so I'm using the trigger for the solid state relay coming from a source that says when the van electrics are switched on, and then when I switch the power off to the van, everything switches off. They also seem to remember the last state, so if they were switched on, they remember they were switched on when you turn the power on, and if they were switched off, they remember they were switched off, which is always very handy, but you can just tap the button then to switch them on if they're not switched on, and then plug in whatever you want to plug into it. So in total, if you add the solid state relay in, you're looking between probably £60 to £75, depending on the price you get things for and whether you actually have any of the bits already, rather than having to buy a pack of bits to do it. And you don't need too many tools for it, just basically a crimper for the connections, a drill with a 30mm hole saw on for cutting the holes out. Anyway, let's get cracking. So to do this job, we're going to be using a drill with a 30mm bit to cut the holes in the blanking plate. We need a blanking plate and a surround. So there's the blanking plate, that's the one I've drilled. And there's the surround. You can use either the C-line or the CBE ones. We need a couple of USB chargers or outlets. I quite like these ones. They've got an on-off switch. They show when the power's on, and you've got two quick charge USB-A's and a power delivery USB-C, and it comes with a nice rubber cap there just to keep the dust out. We also need some connectors. There's out of this connector set I got for using these ones and these covers, and that'll connect onto the terminals there, and we'll connect some wire through them. And some cable. I'm using this twin core cable, which is 2mm conductor, so that should be absolutely fine for carrying the amount of power to these, as we shouldn't expect it to exceed 10 amps, and this should be able to carry 20, so it should run nice and cool. Given the fact I'm tucking it in with insulation, I just wanted to make absolutely certain that it wasn't going to run warm. So using a 30mm bit for these particular USB. In order to mark the centre, what I've done here is just use some post-it notes and just cut the top off, and then we've got a centre mark there. X marks the spot. Now we're going to use a 30mm drill to actually drill on the centre point there. There we go. You should, of course, always clamp things before drilling them and not hold them in your hand. It is worth making sure it's nice and tight at the back here as well, so it doesn't come loose in operation, so just make sure the clip's tight. Little tip as well, it's worth not clipping the frames on until you get them in place, because we're actually going to use these 1, 2, 3, 4 screw holes there to actually screw it into the panel. When we make the hole in the panel, we should be good with a 30mm, as this is about 28mm. We took the cover off so I can feed the wires along here, then down the other side. When running the wires through, it makes sense to put them in flexible conduit so that the wires don't get damaged on any sharp edges. After feeding the wires through, I decided to put some insulation in this void just to keep the van a little bit warmer in the winter and cooler in the summer. So now just measured up to work out where to drill the hole. I'm going to start with this side, which is the passenger side, and I've measured in 10 centimetres and marked it there, and that's 24 centimetres up. It's roughly the centre of the window. I'm just going to double check the measurement on the height. You know what they say, measure twice, cut or drill once. Can't put it back once you've made the hole. That'll sit something like that, which I think looks roughly in the middle. So 10 centimetres there. I'm just going to check the height now. And I've checked behind the panel, and the cutout in the metal is around here, so we've got plenty of space there. And I'm going to use a 30mm drill, the same one we used to make the hole in. It's about 28mm for the USB, and therefore it just gives a little bit of room for just a millimetre or so positioning. So I'm just going to check the height before doing anything else, and then we'll get the drill on and drill the hole. Right, so I'm happy with that, so let's drill. And there we go, one hole. Just clean up these little bits of plastic there. Of course, always check before drilling the hole that it's clear behind, to make sure you don't go through any cabling or anything like that. Let's just test fit this. Just make sure they're not going to drop off down the back. That'll go like that, and then that'll just screw into there. There's 4 screw holes, and then the cap will go on there and clip in place. So what I'll do now is, I just want to make sure everything's good with this, get it screwed in nice and level, and then I'm just going to pop a couple of screws in just to make sure I'm happy with where it is in case we need to do any adjustment. So get on with that now.
Here's where we're going to install it. Just going to measure up and mark that up with a pencil.
So we've marked up this side, again 10 centimetres in, 24 up from the cushion, and just double checked everything looks about right, and then let's make the get the hoover out in a minute. But there's the hole through. So these rough edges off. There we go, and behind here there's our cable. Worth noting, if you've got any insulation behind, make sure it's not around where the charger socket's going to go, just to avoid causing any problems there. Just tuck that back in a moment. Just pop up there. Let's just check that goes in okay there. Yep, all good. Cover will go on and it'll fit like that, all nice and tight up against the back there. Lift it up, plug your cables in to use it.
After pulling the wires through, I then stripped the wires and attached the spade connectors. As well as crimping them, I also soldered them just for extra resilience, and then made sure I put the plastic protective covers on there just to protect the connections. Once I'd done that, I then inserted it into the hole, made sure the wires were tucked behind, put some screws in it, and then of course to finish it off, pop the cover on. And the same at the other side. I didn't video the specifics of connecting it back to the battery because everyone's van's different. This is the circuit diagram of how it's connected up. I'll pop a link to this diagram in the description in case it's handy. Please pop any thoughts or views or how you might do it differently in the comments. Let's take a look at how it works now. So you lift the flap up and then you can turn the power on and off with the button there. You can then plug in your USB-A or USB-C devices. At the moment we've got the drone plugged into the USB-A, but let's swap it for the USB-C and see what a difference it does in terms of the speed of charging.
And there we go, charging up, in this case the drone batteries, using the USB-C power delivery, and it's doing fast charge. As you can see, the LEDs are scrolling quickly. So that's the USB sockets connected up, tested and working. I've temporarily connected them into an existing circuit, but do have a future plan for these ones. So do keep watching if you want to see what I'm up to as the next steps. So I will be moving the connection that I've created into some new circuits I've put in together. But that's for a future video. I didn't want to complicate this one with some of the things I'm working on at the moment, but that should give you a little bit of an idea of what I've actually got up to in the van. Do be careful when working with electrics, even low voltage electrics. Make sure you always check, because you don't want any hassle from these things. You know, the things that you install for convenience and to make things easier, not to create you any additional hassle. So that's that job done. On to the next job now. Thank you for watching. I hope you found this useful, and I'll catch you on the next one. Bye!